Hi, my name is Anthony Brands and I'm studying mechanical engineering at the U of I, and I'm here to tell you a little bit about the Mohr circle. It's a two-dimensional visual tool to analyze stresses and strains in a material. It's one of the most helpful tools I've learned in my curriculum, and it is surprisingly easy to use. Plus, in simple applications, it requires no math. The Mohr circle is used to find the maximums of several values. But first, a little understanding of the different stresses is important. Normal stresses are either compressive or tensile and can be best visualized if compared to a slinky. If you pull on a slinky, a normal stress is applied and it stretches. When you let go, this stress goes away and it returns back to its normal state. Shear stresses are square or rectangular shapes that deform into parallelograms. This is like if you push an eraser back and forth and it stretches in either direction. Stresses and strains are powerful forces, and if not accounted for, then it can be catastrophic, similar to this bridge to the right. The Mohr circle is a great way to be able to visualize and calculate these forces at their max and help engineers avoid such disasters. The Mohr circle graph is set up very similar to an XY plot, except the X value is the stress and the Y is the strain, with the negative Y being the positive strain. In order to be able to draw a Mohr circle, one must start by placing the coordinates of the stress and strain on either side, as seen in the drawing, and then drawing a reference line in between these two. This line will be used for parts seen later. Now that we have reference points, the Mohr circle can be drawn. The principal stresses are located on the x-intercepts and can be seen on the right as well. These are the maximum stress values that can be produced and act on the principal plane. If the circle is drawn to scale, a ruler can be used to measure from the origin to these points and find the values of these stresses. These are the points that show how hard a material will either be compressed or pulled on and are vital in selecting material. The maximum shear force can be found at the lowest point of the circle. This force is the max shear force that could be applied to the material under these circumstances and can also be measured with a ruler. If this force is too great, the system will fail for the same reason you can tear open a Skittles wrapper. By applying a great enough shear force, the wrapper tears open. The transformation angle is a vital component because it shows how much a material needs to be rotated in order to reduce the shear and maximize the stress. This is known as the principal plane. This angle can be measured with a protractor, but is where things get more advanced and is used more for later applications of shear and stress. In closing, the Mohr circle is a very powerful tool to find stresses and strains, and it also requires very little math. The values acquired from the Mohr circle can be used to select materials that won't fail, so we will have a more structurally sound environment.